for finding DL by DW, first we need to find the loss with respect to output over here, and that is nothing but max pooling. It will be given by max pooling. So whatever the output we get, this thing after max pooling and all those things, we will convert it to a convolution image length. This gradients will be passed to that particular location, other will be 0, that will be dl by dx dash. dl by dx is this gradient which we receive from dense layer or fully connected layer. For like what are the derivative we will get for max pooling layer, that is those things. Using those value gradients which we have received from dense and fully connected layer, we will calculate for max pooling layer. Those are dl by dx, and that is indeed useful for finding for convolution dl by dx dash over here for convolution layer, and that is used to find dl by dw in this way. How? As I have said, this is we are getting, and d out by d filter is nothing but the image thing itself. That means it's like xij only. Like again, index will be different. Like for this example, it is xij, and as I have I plus x and j plus y, and sigma notation you can get like this, and yeah, it's pretty much sum of those products. So we can find derivative of loss with respect to weights. So this thing is useful for finding the gradient descent for the filter weights. So this is the thing actually. So we have totally discussed from starting onwards, like how. So we have talked about mathematically how back propagation happens in convolution layer. So with little differences, that's the same for pooling layer also. We can infer for back propagation for pooling layer similarly. And then we have seen mathematically how back propagation happens in fully connected dense layer, and how those propagation happens to happen in, like how those get transfer in backward manner for pooling and convolution layer also intuitively. So we have seen like for all layers mathematically and intuitively. And so this is a little bit forward propagation we have seen, and backward propagation seen both like mathematically and intuitively. So this is like whole structure, and these things happen to be in a combination in different layers, like convolution pooling with different number of times. This can be there into x times, it can be there, and then we get fully connected or dense layer. So combination will be like endless, all the permutation combination, whichever architecture suits for your example, then that is whichever gives better accuracy and better results, less prone to error, so that will be suitable. And different architecture are there, like VGG, RESTnet, and ImageNet, DenseNet, AlexNet. So again, VGG 16, VGG 19, RESTnet 50, 52. So number of layers actually those numbers means. So different architecture suits different problems, and each has some problems, like some pros and cons, and others solves those issues which other layers have, others solves the cons which other layers have. So like these are the things using different combination and different architecture. These like named architectures are designed. So that's it from now. Thank you.